Lesson 6.6, Inequalities. An equation is an equality. It's a statement that two values are equal to one another. Equation means equal, and it will contain an equal sign. An inequality is a statement that two values are unequal, and it will provide an indicator as to which value is higher or greater. It will contain one of the following: this symbol, which is read as is less than or is fewer than; this symbol, which is greater than or is more than; we have is less than or equal to or at most; and we have is greater than or equal to or at least. Solving an inequality is using the same steps as solving an equation, and there's only one major difference. The first step will be to distribute, if necessary. Distribution is not always in the equation or inequality, but we do it if it's there. Then we collect like terms on each side. We'll do adding or subtracting in an attempt to isolate the variable. And finally, we'll multiply or divide. If we divide by a negative, we have to flip the inequality system. This is the major difference that I just mentioned. So first we'll start with single-step inequalities. Here's a few single-step inequalities. So to start this process, we'll look at the first example, which is 3x is greater than 18. Our first step will be to divide by 3 on both sides, just as we would if this was an equation, because the 3's will cancel. And we will receive or get x is greater than 6. Our next inequality is x divided by 5 is greater than or equal to negative 13. So first I'm going to rewrite that so I can have room to show the next step. It's 13. To undo division, we'll multiply both sides by 5 because these 5's will cancel, which will leave us with x is greater than or equal to negative 65. Next, we have x minus 6 is less than or equal to 21. Our first step will be to add 6 to both sides, which will give us x is less than or equal to 27. Finally, we have negative 6x is greater than 36. Here we're going to be dividing both sides by negative 6, which means we're dividing by a negative, and that means we need to flip the inequality. I just draw that to kind of remind you that we have to flip the inequality. So anytime you multiply or divide by a negative, flip the symbol. That gives us x is less than negative 6. The reason we need to do this is because multiplying or dividing by a negative changes the truth value of the inequality. For example, if I have 2 is less than 5, but I multiply both sides by negative 1, I get negative 2 and negative 5. Negative 2 is not less than negative 5. Negative 2 is greater than negative 5. So that's why we have to make this flip. So next we'll solve some two-step inequalities. Here are 4 more examples. In our first example, negative 3x minus 5 is less than 10. So the first thing we'll need to do is to add 5 to both sides. This will give us negative 3x is less than 15. We then divide both sides by negative 3. And we divide it by negative, so we need to flip that inequality. That will give us x is greater than negative 5. Our next example, x divided by 3 minus 3 is less than or equal to negative 6. Our first step will be to add 3 to both sides, which gives us x divided by 3 is less than or equal to -3. To clear our division, we'll multiply both sides by 3. These will cancel, which will give us that x is less than or equal to -9. Now, you'll notice that I was multiplying and there was a negative involved, but I didn't multiply by a negative, therefore I did not have to flip the inequality. Next example, -x plus 2 is greater than 7. First, I subtract 2 from both sides. Next, I have -x is greater than 5. Now, I don't want to know what -x is. I want to know what x is. So, in order to clear this negative, I can multiply both sides by -1 or divide both sides by -1. And if I do that, I need to flip my inequality symbol. That will give me x is less than -5. Now, you don't necessarily have to incorporate this multiplying by -1 step. If you have a negative variable, you can change both signs and flip the inequality. And just remember to flip the inequality and you can solve it that way. Our last example on a two-step inequality, I have 4 plus x divided by 6 is greater than or equal to -5. My first step is going to be to subtract this 4. That will give me x divided by 6 is greater than or equal to -9. And then I'll multiply both sides by 6. And I will get that x is greater than or equal to -54. So those were the two-step inequalities. Next we have multi-step inequalities, and I have two examples, one with variables on one side and one with variables on both sides. Now, we had mentioned before that the first step will be distribution if necessary, and this problem has distribution in it, so we'll need to do that. Now, here I have -3 minus 6 times 4x plus 6 is greater than -11. So I need to distribute this. And it's very important that you remember to bring the negative with the 6 when you multiply it in, so that you're changing signs as necessary. This negative is like this 6's car keys. It can't go anywhere without them. Once I do that, I have -3. -6 times +4 will give me -24x. -6 times +6 will give me -36. It's greater than -11. The next thing I need to do is combine like terms. I have -3 and -36. Those are like terms. So I'll add those together to get -39 is greater than -11. Add 39 to both sides. And I get -24x is greater than 28. Divide both sides by -24. And you get that x is less than, we divided by negative, so we had to flip. Now 28 does not divide evenly by 24, but this is a reducible fraction. I have 28 over 24. They'll both divide by 2 to give me 14 over 12, which will both divide by 2 to give me 7 over 6. Now I have this negative in the denominator, but we don't leave negatives into the denominator. We'll bring them out front. So this will be x is less than -7/6. For our last example, I do have some more distribution. I need to remember when I multiply in to bring that negative with me. So it's -3 times 5 and -3 times 7a. On the left-hand side here, I have nothing to do, so I'm going to just rewrite that. -3 times 5 is -15. -3 times 7a is -21a. I'll add 21a to both sides to get all of my variables together. This will give me 30 plus 15a is less than negative 15. Subtract 30 from both sides to isolate the variable. And we get 15a is less than negative 45. Next, I divide by 15 to get that a is less than negative 3. Okay, now we need to graph inequalities. And the graph of inequality with one variable is graphed on a number line. So we should probably make a note of that with one variable. We will be graphing inequalities in two variables later on in the algebra course. Here's our number line. The graphs use circle and shading to indicate all of the values that make the inequality true. Because we have an inequality, for example, x is less than 3, there's more than one number that is true. 2.9 is less than 3, negative 76 less than 3, 0 less than 3. So we have to have a way to indicate that there are a lot of numbers that make this true. We use an open circle on our graph if we have a less than or a greater than, and an open circle is a circle that is not filled in. We use a closed circle on a graph with less than and or equal to and greater than or equal to, and a closed circle is a circle that is filled in or colored in. Okay, so how we graph the inequality is the first step is we need to solve it. So I'm going to go through and solve this quickly. We add 5 to both sides. We get negative 3x is less than 15, and then we divide by negative 3, and so we have to flip our inequality symbol, and we get x is greater than negative 5. So here's our solution. This is the first step. Then we create a number line. Now, depending on who you work with, some people are very particular about the way number lines are filled out. Some people are not. I tend to go on the less particular side. So my number lines, typically I put a 0 somewhere in there, and then I put my solution number on the correct side. And they're very sort of empty. Other people really want those numbers, filled out. So you have 1, 2, 4, 6, negative 2, negative 4, negative 6, etc. It just depends. But so we need to create the number line. Then you want to put an open or a closed circle on the solution number. Here our solution number is negative 5, and we need an open circle. So we put an open circle on negative 5. I'm going to just do this on both graphs. Then you shade the number line on the correct side of the circle. And by the correct side of the circle, it's the side with the true values. Some of you may have done this in the past and been told to shade which side the arrow points. This only works if the variable is on the left. If you learn to shade the true values, it won't matter where the variable is located, and it won't matter which way the arrow is pointing. You'll just know which side is accurate. So we're looking at this. We have x is greater than negative 5. Okay, that tells me all the numbers that are bigger than negative 5 are going to make this true. Over here we have negative 6, negative 7. Those are smaller than negative 5. And over here I have 0, 2, 7, greater than. So I'm going to shade the side where the numbers are true. Keeping in mind that if you have an open circle, you want to keep that open. Don't color it in. So here are a few examples. We're going to solve and then graph these. So for our first, I have some like terms here that I need to combine. So I have -2 is greater than or equal to 4p plus 10. I'll subtract 10 from both sides, and I get -12 is greater than or equal to 4p. Then I'll divide by 4, and I get -3 is greater than or equal to p. And this is one of those times where it makes sense to learn not to rely on which way the arrow is pointing. Here's why. I have 0, and I have -3, and I have a closed circle because I have a less than or equal to, and p, -3 is greater than p. That means p is going to be over here on this side with all the numbers that are smaller than p, or sorry, smaller than -3. And you see I did not shade the way the arrow was pointing, and that's because my variable was not on the left. So just keep that in mind. Here I have 33 plus 4x is less than or equal to -x plus 7. This negative outside needs to be distributed in. So 33 plus 4x is less than or equal to -x minus 7. Then I can add x to both sides, remembering that, of course, if there's no coefficient, that's the same thing as a 1. So I get 5x is less than or equal to -7. Subtract 33 from both sides, and I get 5x is less than or equal to -40. Divide by 5, and I get x is less than or equal to -8. I have 0, I have -8. Closed circle because of less than or equal to, and the numbers that are less than or equal to -8 are on this side, so we'll shade over here. Next example is 2 times 6 plus 4n is greater than 12 minus 8n, and then we have -3 times -7p minus 6 is less than p minus 29. What I would like you to do now is pause the video for a moment, try to work these problems out, and then graph them and see how you do. We'll go over them after you unpause the video. Okay, so let's check your work. I've written out all of the steps. You should have gotten n was greater than 0, open circle and shaded to the right. And then you could have gotten p is less than -47/20, open circle and shaded to the left.